Okay, Matthew and Caleb, we're going to finish these problems that are left over from today's video very quickly. So here we go. I believe we're starting on page, well, you guys should have record there. You had some sheets to take with you. So we're looking at these problems here in which we're solving some linear equations. So let's go pretty quickly. Let's solve number 1. Bring the 5 over and make it a negative 5. When you combine, you would get 16. You're left with 4x over here. Divide both sides by 4, and x equals 4. Okay, hopefully we will strike that correct balance between not going too fast and not going too slow. I hope that made sense to you. Moving on to number 9. Alright, a simple linear equation. I'm going to bring my 2y over here and make it negative, bring my 1 over here and make it negative. So I have a negative 2y over here. I have a negative 1 here. Y minus 2y is negative y. Negative 7, negative 1 is negative 8. There's really a negative 1 here. So we're going to divide both sides by a negative 1. And if we do that correctly, y equals 8. Okay? Y equals 8. Number 13. Bring your 2x over, and when you bring it over, it becomes a negative 2x. Bring your negative 5 over, it becomes a positive 5. And 3x minus 2x is 1x, or just x. And 1 plus 5 is 6. So pretty simple, pretty easy linear equations. Okay, still solving linear equations. Take your 3 and multiply it through so that we are able to simplify the left side. Over here on the right side, you take your, not a 2, but a negative 2. Take your negative 2 and multiply it through. Negative 2 times 3, negative 6x. Negative 2 times 4, negative 8. Now we're going to go ahead and simplify our right side. Our left side cannot be simplified because we have unlike terms. Over here we would have negative 3, negative 6x, because a negative 8 and a positive 5, when you combine them, gives you a negative 3. And now we're ready to move stuff around. See this negative 6x? We're going to bring it over and make it a positive 6x. See this positive 3? We're going to bring it over and make it a negative 3. And we're left with 9x equals a negative 6. We're going to divide both sides by 9, and if we do that correctly, we'll get a negative 6/9, which would reduce to a negative 2/3. Alright, moving on to the next problem. Okay, number 67. Now, I don't have my book with me, so I'm going to have to reach over. Give me just a second, guys. Number 67 here. Okay, now let's see here. I'm usually pretty organized, guys. I apologize. Let's see here. Number 67 is on page 199, it looks like. So let's turn over to 199 and see what the instructions say. The instructions say to... No, that would not be the right page. This must be page 188. Alright, number 67 says to find the 0. So we're going to find the 0 of this linear equation. Now, whenever you're finding the zeros of a linear equation, let's not forget what that means. That means you're finding the x-intercept. So when I ask you to find the zeros of this function, I'm really asking you to find the x-intercepts. And anytime you're looking for the x-intercepts, you put 0 in for y. Well, f of x can really be looked at as your y. So I'm going to put 0 in for y equals 16 minus x. And now let's solve for x. Bring your 16 over, becomes a negative 16. 0 minus 16 is negative 16 equals negative x. And then divide both sides by a negative 1, and 16 equals x. So there's your 0, or your x-intercept, whatever you want to call it. So your x-intercept, or 0, for number 67 is 16. Now, number 83, I believe, says the same thing. I believe 83 says to find the zeros and find the x-intercept. Well, the x-intercept, obviously, when you look at this graph, the graph passes through negative 4. So my x-intercept equals negative 4. Then it says to find the 0 of this graph. Well, remember, when I ask you to find the 0, that's the exact same thing as finding the x-intercept. So the 0 is also negative 4. Okay, so the x-intercept is -4, the 0 is -4. Okay, moving on to number 2, and if you would just allow me this one quick check to see what page we're on. It looks like page 213, I believe. Let's turn over there and see if that matches this problem. I believe it does. Yes, it does. Okay, we are solving this problem. Now notice it's already factored for you, so you really just have to take each group and set each group equal to 0 to solve, and I know you guys can do that pretty well on your own. If you solve this group, you will get 2/5, and if you solve this group here, you would get -3/2. No need to check your answers on these. They're just a factored polynomial equation, pretty simple. Okay, moving on to number 3. Now they ask you to solve this. Well, I mean, we notice right away it's a quadratic, so the first thing we like to do is we like to factor if we can. Notice we have a lead coefficient of 1, so the factoring should be pretty easy. I'm thinking of using these two numbers right here. If I multiply these two numbers, I get a positive. Well, I want a -20, don't I? So maybe this isn't factorable. Let's see. Let's see, we'd have to use a 4 and a 5, a 2. Yeah, that would work. I was actually almost right. How about this? If you multiply those two numbers, you get a -20. I'm still wrong. Sorry about that. If you multiply those two numbers, you will get a -20. If you combine them, you'll get a -8. So sorry about the mistakes there. Here's your factorization. X plus 2, x minus 10 equals 0, and then of course if you set each group equal to 0 and solve, you will get -2 and +10 for your two answers. No need to check them on a simple quadratic equation. Alright, number 7. Now really guys, look, all that you have is an x squared. So if you will simply just get x squared, if you'll simply get x squared all by itself, that's all you have to do on this. If there's no x term anywhere, just get the x squared all by itself. So if you bring the 12 over and make it positive and then divide by 4, you're left with this right here. Again, bring the 12 over and make it positive, then divide by 4 and you're left with 3. Now take the square root of both sides and you will get x equals positive square root of 3. And there we go. Pretty simple. Okay? All right, moving on to number 15. Well, I do have an x squared term and I do have an x term. So we're really going to have to get one side equal to 0 like we like to do with quadratic equations. And you are going to have to factor this. Now, of course, when you factor this, you pull out what's common. Okay, so I got one side equal to 0. The reason I didn't solve this like the last problem is notice I had only an x squared. There's no x terms anywhere. And when that happens, you can get the x squared by itself and then solve. In this problem, we have x squared terms and we have x terms. So you're going to have to get one side equal to 0 and then factor if you can. And in this case, we can factor. There we go. Pull out a 2x. 2x times x is 2x squared. This will be a 3. I'm just making all kinds of mistakes today. 2x times -3 is a -6x. Now if you take 2x and set it equal to 0, divide both sides by 2, x equals 0. If you take x minus 3 and set it equal to 0 and solve, you will get x equals 3. There's your two answers for your quadratic equation. Alright, now number 19. Let me get a drink here real quick. On number 19, you realize you have 4 terms, and notice they're set equal to 0. Now the best way to solve these is always try to factor first, and the best way to factor these is to factor by grouping. In other words, pull out what's common in the first 2 terms, and then pull out what's common in the second 2 terms. And by the way, one of these is on your test, okay? One of these types of problems is on your test. So if I pull out what's common in the first 2 terms, that's only an x squared. I'm left with 7x plus 1, I think. Let's check my work and see. X squared times 7x is 7x cubed. X squared times 1 is x squared. Now, remember today, Matthew, we were talking about this. Whenever these two terms, whenever the first term out of these 2 terms is negative, you put a negative sign. If this would have been positive right here, then you put a positive sign. Okay, it's always going to be that way. Now, there's nothing you can factor out, so we pull out a 1. Now, what I'm going to do is I'm going to go ahead and put 7x plus 1 right here because that's what I have in my other parentheses. But I got to check and make sure it works. Negative 1 times 7x is negative 7x. Negative 1 times 1 is negative 1. So we're doing really well, actually. You write your matching parentheses one time, and then you're left over with x squared minus 1. And now you cannot factor this parentheses here anymore, but you can factor this parentheses right here, x squared minus 1. Remember, it's called the difference of two squares. We know the square root of x squared. We know the square root of 1. The first term is positive. The second term is negative. So here we go. The square root of x squared is x, so I put an x here and an x here. The square root of 1 is 1, so I put a 1 here and a 1 here. Make one positive, make one negative. And now, if I take each group and set each group equal to 0, let's see what I get. This group here would be negative 1/7. Again, I don't have to do that for you. You guys know how to solve these simple equations. For this group here, x would equal a negative 1. And for this group right here, x would equal a positive 1. There's your answers. No need to check those. There are your three answers. Okay? All right, moving on to number 23. And I believe the directions say to find the x-intercepts and the zeros. Well, okay, that's pretty easy. I mean, whenever I ask you to find the x-intercepts of a graph, you simply just look at the graph. Here's one, and here's the other. So the x-intercepts are negative 1 and positive 3. Those two numbers are where the graph crosses the x-axis, thus we call them x-intercepts. Then the directions say to find the zeros. Well, guys, zeros are whatever the x-intercepts are. So your zeros would be at negative 1 and 3. So there are your zeros. All right, number 35. Number 35 says to solve using the quadratic formula. Negative b plus minus the square root of b squared minus 4ac all over 2a. Now, you never ever want to use the quadratic formula unless you have one side of the quadratic equation equal to 0. So bring your 15 over, make it negative. And now we know that a equals 1, b equals negative 2, and c equals negative 15. So let's make our substitutions. There's already a negative sign in front of b. I'm putting a negative 2 in, so a negative negative would give me a positive 2. And then plus minus, put your square root. Okay, b squared. Well, I can square negative 2 in my head. Negative 2 times negative 2 is a positive 4. Then I like to bring down my negative 4 and do AC in my head. A times C. 1 times negative 15, that would be a negative 15. And then we can do 2A in our heads. 2 times 1 is 2. Now next, I like to simplify my radicand. All of this under the radical. So next I would have 2 positive negative. Negative 4 times negative 15 is a positive 60. Do your multiplication first. Negative 4 times negative 15 is 60, plus 4 is 64 all over 2. Now 64 is a perfect square, so next I would have 2 positive negative 8 all over 2, because the square root of 64 is 8. Now I can write this two different ways. 2 positive 8 all over 2, and 2 negative 8 all over 2. So this fraction here would give me an answer of 5, right? Because 2 plus 8 is 10, 10 divided by 2 is 5. And this answer, this fraction here would give me an answer of negative 3, right? I mean, 2 minus 8 is negative 6, and negative 6 over 2 is negative 3. Okay? All right, moving on to this problem here, number 62. Now on number 62, the directions ask us to find the zeros. Find the zeros. So if I'm finding the zeros, I'm really finding the x-intercepts. And if I'm finding the x-intercepts, I put 0 in for y. So I put a 0 there, and then I go ahead and solve this equation. Now this factorization is very simple. It's a quadratic lead coefficient of 1. So if I multiply these two numbers together, I get a negative 2. If you combine these two negatives, you get a negative 1. So the factorization would be x minus 2, x plus 1. All right? So If you take each group and set each group equal to 0, you'll get a positive 2 and a negative 1. So those are your zeros, or we also could say those are your what? If they're your zeros, they're also your x-intercepts, the exact same thing. All right, number 67. We're finding the zeros of this function, and of course f of x is y. Where the y is, I substitute 0, because anytime you're looking for the zeros, you're really looking for the x-intercepts. Now, this cannot be factored. By the way, if you're looking for closure, this is our next to last problem, Matthew, Caleb, and we'll be finished. So actually a pretty short video. Now, you cannot factor the right side here, so you're going to have to use the quadratic. So here we go. Negative b, let's go back here and copy and paste it so we can save some time here. Or just move it, I guess. All right, here we go. Now, already one side's equal to 0, so my a is 1, b is 2, c is negative 5, so negative b, b is 2, so negative 2, positive, negative. Okay, the square root of b squared. Well, b is 2, 2 times 2 is 4, and then minus 4 ac. A is 1, c is negative 5, 1 times negative 5 is negative 5. All over 2a, 2 times 1 is 2. All right, now we're going to simplify the radicand right here. So I would have negative 2 plus minus the square root of 24 all over 2. Okay? Now, there's many ways to finish this. I don't have my calculator in front of me, guys, but you could type into your calculator and listen to me very carefully. Negative 2 plus the square root of 24. Then be sure and hit enter, and then divided by 2, enter, and you'll get out one answer. Then type into your calculators negative 2 minus the square root of 24, enter, divided by 2, enter, and you'll get out your other answer. Now they're going to be decimals, and you'll have to round them off. Another way to do this would be negative 2 plus minus the square root of 6 times 4. Break down 24 into 6 times 4, and then you know the square root of 4, so cross it off and put a 2 on the outside, because the square root of 4 is 2. And then reduce the whole thing by 2. So this would become a 1, this would become a 1, this would become a 1. So you would have negative 1 plus minus the square root of 6 all over 1. And you don't have to put it over 1 if you don't want to. And this would also be an acceptable answer. Either one of those, okay? So this here, these would be the zeros, or you could call them x-intercepts if you would like. Okay? All right, moving on to the last problem. We're finished. Okay, we have an absolute value inequality. Now, step 1 is isolate the absolute value. That's already done. And then next you realize you have greater than, so you know right away your answer is going to be a disjunction. And then I've taught you to write the inequality just like it is. Don't change a thing, except you drop the inequality bars. And then you write this inequality again right over here, only you flip the arrow and you change the sign of the 5. And now we're ready to go. For this inequality here, I would just simply multiply the entire inequality by 3 over 1 to get rid of my fractions. So 3 over 1 times this fraction will leave me with 2x plus 1. Greater than 15, because 3 times 5 is 15. Bring the 1 over and make it a negative 1. That would be 2x is greater than 14, and divide by 2, x is greater than 7. And then over here on this inequality, multiply the entire inequality by 3 over 1 to get rid of your fraction. 3's would cancel, leaving you with 2x plus 1. Less than 3 times negative 5 is negative 15. Bring the 1 over and make it a negative 1. 2x is less than negative 16. And then divide by 2. X is less than negative 8. Now if you were to graph that, trust me, you would get one direction going to the left and one going to the right. We knew it was going to be a disjunction already because we had a greater than sign here. So all that you have to do is put the word or and you're totally finished. Okay, so that's it. Good job today in class. By the way, I know it's not easy to sit for 2 hours. Y'all did really well. I hope this video has been a help to you guys. Your tests are due by Wednesday, and so make sure you get those turned in, all questions answered, everything done in time, and be sure and do the review sheet if you want the bonus points. Okay, call or email if you have any questions.